Hi, students. We're going to cover 11.9, which is density. So density based on area. Density is a measure of the quantity of some physical property per unit of length, area, or volume. One example of density is population density, which is the measure of population per unit of area. It's calculated for states, major cities, others for the U.S. Census. So density is the ratio of the objects to the area. So number of objects per area is the idea of density. Density, you should know from science, is mass divided by volume. So that's also the idea here, but this one is what we're going to be talking about for the most part in this one. Okay, so the country with the largest number of active volcanoes in Indonesia, with 147. The area of Indonesia is this. So there's the area, there's the number of active volcanoes. What's the density of active volcanoes? So if we come back to this, we're going to talk number of objects divided by the area. So we're going to do the number of volcanoes, 147, divided by the area. And we're going to divide that out and get ourselves an answer of 0.0002. And so we would get A for that case, but that's what we are solving in that one. Okay, so that's number per area there. The duck pond example, so I am on page 700. For a school carnival game, Adeline is planning to fill a duck pool with water and float a layer of ducks on top. She knows that it takes 25 rubber ducks to fill 1 square foot of area. Notice we're using area here. The pool used for the carnival has an area of about 7 square feet. How many rubber ducks should she buy to fill the pool? So we're talking area. We could talk volume here because we're talking about a pool, but we're talking about just the top layer, float a layer of them. So we're talking area. So 25 rubber ducks to fill 1 square foot. You can do this lots of different ways, but what I like to look at here is 25 per 1 foot. And then we're trying to say how many per 7 square feet. And so we can set up a proportion in this case. Multiply 7 by 25 here, and you're going to get 175 rubber ducks. Because you would do that, you'd get 175 equal to 1 times x, which is just be x, and that is your number there. Population density then. So city in Philippines, most densely populated, it has this many residents, so that's the objects. Share a space that is a rectangle that is 5.1 miles long by 2.9 miles wide. So we have the dimensions for the area, but we need to solve for that. So we know that the number 1,650,000 divided by, we're going to do 5.1 times 2.9. And this is going to be people per, so divided by square mile. And when we multiply these, we're going to get a squared mile in that case. So you do this, and again, it's what we multiplied down here just to make sure we understand that. And if you do that, you should get 111,562 people per square mile. Okay, as long as you're approximately there, that's what you get. If your decimals aren't coming out exact or whatever, or you're not getting enough numbers, please let me know so we can talk about the calculations of that. Okay, so density based on volume. So that was all density based on area. Again, we talked about in the duck pond one, we could have talked about volume in this case, but the ducks were all on top, so that's why it was area. So density based on volume is just the number of weight divided by the volume. So this is my density is equal to mass divided by volume. Mass in this case is considered that number of weight or whatever, and you can solve there. So you've got your density with those. Oh yeah, I didn't put an example problem in here because you've done enough of these, but there are some examples in the book if you wanted to look at them to do those. Okay, so you have 1 through 11 odd and 13 through 16